And now we finally get to the most exciting part, the word problems. Let's do it. Okay, so here we have, in number 5, we have a question which is, a piece of cloth is 4 1/2 meters long. Amandeep used 2/5 of it. What length did he use? Let's try to do it. So that's number 5. Amandeep used 2/5. It's very important to be able to read properly the word problems because they're not so much about maths as they are about understanding of English in this case. You have to try and figure out what do they actually want from you in this problem, right? So in this case we have the piece of cloth which is 4 1/2 meters long. I think I can make a small drawing for you on this topic. So we have a piece of cloth which is 4. I'm not sure this is how the piece of cloth looks like, but okay. Should be fine, right? Let me move it. Okay, so a piece of cloth which is 4 1/2 meters long. So the total length is 4 1/2 meters, and he used 2/5 of it. So out of this whole piece of cloth, he only used a small part of it, which is 2/5. I don't know how much exactly is 2/5. Just thinking. And what length did he use? So we have to find 2/5. You have to find 2/5 of 4 1/2. How much is it? How can we find 2/5 of 4 1/2? So in fractions, of means multiplication. If we are talking about fractions, of means multiply. So to find it, we have to multiply 2/5 by 4 1/2. And the answer is going to be, first we have to convert it to improper fraction. So it's going to be 2/5 times, it's going to be like 9/2, and then the answer is going to be 9/5, which can also be written as 1 and 4/5. That's it. Let's do number 6. It takes 3 3/4 of hour to plaster a wall, right? Okay, let me paste it first, and I will read it then. It takes 3 3/4 of an hour, 3 3/4 of an hour to plaster a wall. 1/3 of this time is spent mixing the plaster. How long does the actual plastering take? Okay, let's do it. So how long does the actual plastering take? So 1/3 of that time is spent mixing the plaster. So this is our total time. I will make it pretty. Oof, not that pretty. Yeah, something like this. So 1/3 is spent mixing the plaster. 1/3 of this time is spent mixing the plaster. Let me do it properly, like this. Yeah, I'm still figuring it out. Okay, 1/3 of this time is spent mixing the plaster. How long does the actual plastering take? So this is how much we spent mixing the plaster, 1/3. So what we have left is we have 2/3 left. 1/3 for mixing the plaster, and 2/3 for actual plastering. So 2/3 here and 1/3 here. So we have to find 2/3 of, and we know that in total it's 3 3/4 of an hour. Right? So we have to find 2/3 of 3 3/4. How do we do that? The same like in the previous one. So of means multiplication. So 2/3 times 3 and 3 over 4. 3 and 3 over 4 can be converted to 3 times 4 is 12 plus 3 is 15, so it's 15 over 4 is equal to 30 over 12, which is equal to, it's going to be 2 and 6 over 12, which is equal to 2 and 1/2, which is our final answer for this question. Finally, we got it. Okay, what else do we have? I think I'm going to, okay, 7 is interesting. I don't want to skip that. 7 is interesting. Let's do it together. Janice bought 6 1/2 meters of cloth. She used 1 1/4 of meters. What fraction did she use? All right, she used 1 1/4 of meters. What fraction did she use? The way to think about it is, I think I will give you another example. Let's say you have 8 apples in total. So example, there is 8 apples in total. I ate 2 of them. The question is, what fraction of apples did I eat? So the answer here is 2 out of 8, which can be written as 2 out of 8. We write it like this, right? Which can be written as 2 over 8, which can be simplified. If we divide them both by 2, it can be simplified to 1 over 4. So look at this, look what we do. We have 8 apples in total. 8 apples in total. Okay, so 8 apples in total. So here in total we have 6 1/2 meters of cloth. And so she used 1 1/4 of meter, which is like 2 apples that I ate, right? Let's do a connection. So to find it, we have to do 2 over 8. So here for the cost we have to do 1 and 1 over 4. It's like 1 and 1/4 divided by, or we can write it like this, right? Over 6 and 1 over 2. Like this, which can be written as division as well. So 1 and 1/4 divided by 6 and 1/2. So we have to convert them. So it's going to be 5 over 4 divided by, and then we have 13 over 2. We have to flip them. I have to make this smaller, I think. Too big. Yeah, that's better. And then it's equal to, we have to flip them again. So the answer is 5 over 4 divided by, multiplied by 2 over 13. So we get 10 over 4 times 13 is 52. 10 over 52. We can divide it by 2 at least. They're both divisible by 2. So we get 5 over 26. And this is our answer. This is actual answer. And example is example, right? It's not the same thing. So I think I'm gonna outline it somehow. Okay, so that's interesting problem, I would say. It's a little bit confusing, so they try to kind of trick you in this regard. Okay, I hope this makes sense. All right, and let's get to the next part of it. Okay, so there's more fraction problems, more similar stuff. Let's do. Okay, let me see. So a 10 halt. All right, let's do a 9. Let's do number 9. It's getting complicated. It's getting complicated, I would say. I'll try to give you some examples. So a tin holds 5 and 1/2 liters of oil. How many 2/3 liter cans can be filled from it? How many? So what we have to do is normally, like let's say if there's 10 liters of oil, let's replace it. 10 liters of oil. So what I'm trying to do is I'm trying to give you an example which has easier numbers. And if numbers are easier, then you can just like logically solve it. So let's say there's 10 liters of oil, and let's say it's 2-liter cans. 2-liter cans. So in this case, you know what you need to do, right? You have to do 10 divided by 2. For example, if you have, let's say we have 10 liters of water, and we have 2-liter bottles, right? So you can figure it out quite quickly. It's going to be 5 bottles. Like you don't even think about this, right? But actually you have to do the operation. You have to do 10 divided by 2, which is equal to 5, right? 10 by 2 equals to 5. Again, this is an example, not an actual solution. And the solution is going to be here. Solution. What you have to do is you have to compare this easy example with not so easy, confusing fractions part. So 10 liters of oil, 2-liter cans. So instead of 10 liters of oil, we have 5 and 1/2. Instead of 2-liter cans, we have 2/3 liter cans. But still the procedure should be the same, right? We do 10 divided by 2. It means in this case, if we have these numbers, we should do 5 and 1/2 divided by 2/3. This should be the course of action. So we do 5 and 1/2 divided by 2/3. And of course, we have to make it into improper fraction first. So we do 11 over 2 divided by 2/3. We flip it like this. And then we get 11 over 2 multiplied by 3 over 2, right? Which is 33 over 4, which can be written as 8 and 1 over 4. Okay, next one. A piece of food. All right, this is similar. Number 10 is almost the same. I think I'm going to do something different. A man's work day is 8.5 hours. Okay, let's do this. They even give you a hint, so that must be really hard. Kind of. So number 11, let's do it. A man's work day is 8.5 hours. 8.5 hours, we can say, right? He spends 3.25 of an hour dealing with customers and the remaining time working in his office. What fraction of his work day does he spend with customers? What fraction is it? I think we did this. You can look at the question number 7. We found what fraction, again by dividing. So we have to divide in A. In A we have to divide the smaller number, which is 3 and 1/4. We have to divide it by 8 and 1/2. Okay. What fraction dealing with customers? Okay. So we do this division, right? We need to convert them. It's going to be 13/4 divided by 17/2. Again, we flip it. We have to flip it. We get 13/4 times 2/17. And we cut it like this. And then we get 13 divided by, and we have to do 2 times 17, which is 34. So 13/34 is an answer. Okay, and B is interesting. What fraction of the whole day is he in his office? So whole day has 24 hours in it. And out of these 24 hours, he is in the office for quite a long time, I would say, actually. Quite a long time, 8.5 hours. Well, similar to me when I will be back in school. So what do we do is we do 8.5. So what fraction of the whole day does he spend in the office? How can we find this? We have to do, so what we did before, now we have to do 8.5 divided by 24. Out of the whole day, out of 24 hours, he spends 8.5 hours in the office. So it's 8.5. Okay, let's write it like this. Let's write it like this: 8.5 out of 24. And out of, in terms of fractions, it means division. So it's going to be 8.5 divided by 24, which is going to be 17/2 divided by 24/1. We can divide like this quite easily. And then we flip it. We get 17/2 multiplied by 1/24, which is 17/48. This is what fraction of day he spends in an office. Okay? Okay. Alright, and I think we can do something else. 13. This is a really challenging one. At least that's what the book says, because they make it this interesting color. Let's do it. Let's do this. Whoops. Okay. 13. In 13 we have, what are the numbers P, Q, R, and S if, and then we have A, 2 to power P equals 4. Okay, 2 to power P equals 4 to power Q equals 16 to power 2 equals 256. Okay, so this question, and I think I will leave you B to practice. B is going to be your homework, ladies and gentlemen. Can you do it? Let's see. 2 to power P equals 4 to power Q equals 16 to power 2. So here we have to find what do they have in common. So it turns out that actually all these numbers, if you think about it, they are all powers of 2. And what we have to do is we have to write it like this. 2 to power P equals 2. 2 to power 2, because this is what 4 is. 4 is 2 to power 2. and then to power q, like this, and equals to 2 to power 4, because this is what 16 is, and then to power 2 equals to 2, 5, 6. Okay, so let's do this. So 2 to power p equals 2 to power 2q. Actually, we probably have to write 16 as 4 to power 2. So it's going to be 4 to power 2 and then to power 2. And this way I think we can figure out, and then we can write, so 2 to power p equals to 4 to power q equals to 4 to power 2, and then to power 2 equals to 256. So this way we can see that 4 to power q is in fact equal to 4 to power 4, because remember I told you in the last lesson x to power a and then to power b equals to x to power a times b. So 2 and then to power 2 equals 2 times 2 equals 4, and then q is equal to 4, like this. So q equals to 4, and we know that 4 to power 4, now we can take it to another, okay, my paper is going to finish. So 4 to power 4 is equal to 2 to power p. Okay, so here what we have to do is, we have to do 2 to power 2 to power 4 equals to 2 to power p, like this. And then we can write it as 2 to power 8 equals 2 to power p, then 8 is equal to p. So p again is equal to 8 in this question. Okay, so q is 4 and p is 8. A little bit tricky, but I think you guys, if you want to, you can try to do b as your home assignment for this question. Okay, I think that's it for today, and see you guys next time.